What is up guys, welcome back to KitGuru. Today we are kicking off another one of our special custom build projects. This time around we're working in partnership with Western Digital, so naturally the system will include some of the most cutting edge desktop storage available. We've also spec'd out a modest gaming system for this build. The system will be based on an Intel Z590 platform. So for the motherboard, we have this MSI Mag Z590 gaming carbon Wi-Fi. CPU is an Intel Core i5-11600K, one of the most value for money CPUs for a gaming system at the moment. In terms of memory, we're using this Corsair Vengeance RGB Pro SL. So this is the latest version of the Vengeance RGB. It's a little more low profile compared to the original, and it's got a slightly different RGB bar on the top. This is a 4x8 GB kit and it's 3600 megahertz. For the storage, our secondary or storage drive will be this WD Blue SN550 2TB drive. This is an NVMe SSD, ideal for storing, games that you maybe play offline, and photos, videos, all that kind of stuff. And then for the main drive that will contain the operating system and our favorite games that are most played, we're going to be using this WD Black SN850 1TB NVMe drive. This is the latest PCIe Gen 4 specification with up to 7000 megabytes per second read speed. So that is currently one of the fastest drives available for desktop systems. Empowering the system is the Corsair RM850 power supply. That should give this system plenty of juice. We're going to be cooling the whole system with a Corsair Hydro X full custom loop. It's a hardline loop and it's going to be using some of the new satin black tubing. Can't wait to see how that looks because I've not used that tubing before. And then for the chassis, we're going to be using this Fantex Eclipse P600S. So this is a case that can be used in different configurations. It can be used like it is now in kind of a silent configuration, or you can remove the top panel. Also, you can remove this front panel as well for a more open airflow layout. Because this build is sponsored by WD, they've obviously sent over the storage and they've also provided some of the other hardware. This system will be going back to Western Digital as well afterwards. Not sure what they're going to be doing with it. Maybe they'll use it in some shows or some kind of centerpiece. Because of that, I want to try and base the overall theme of the system on this WD Black drive. So what I'm thinking is the whole interior of the system, we're going to go with a complete blackout look to it. Some of the custom loop parts, they're already black, so not a lot's going to be needed to be done with those. This motherboard as well, this is going to work perfectly as well, as the majority of the motherboard is either black or it is a dark colour, so that should look great. There's these odd bits of chrome here and there. I might try and do something with those, cover those up. But also you can see on this board we've got some areas that have a carbon fibre effect, so this IO shroud and the heatsink for the chipset as well. So that is one of the reasons why I bought this P600S in this grey colour rather than black, because this grey should make a good base for hydro dipping with a black hydrographic film. You'll see what I mean about that later on in the project. But there are some areas of the case, maybe the motherboard tray and some other bits, that I might have to paint as well. So bring them back to the black theme, or maybe even paint them orange. I don't know yet. I'm not 100% sure, but there is going to be some mods to the case as well. So you're probably wondering by now, where is the graphics card for this build? Well, here it is. This is the ROG Strix RTX 3080. We originally planned to use a 3070 in this build. We thought it'd suit the i5-11600K better than a 3080. It'd be more like the kind of GPU that you would pair with that CPU. But like you guys are probably suffering with during this GPU shortage, we're also struggling to get new samples of the RTX 30 series card. So we've actually picked up this in an already used condition. This actually came to us from another media outlet with this Corsair XG7 water block installed. And for this video, I needed to have this card built back up with the stock cooler on, just to show you guys what card we've got and to just run through the process of removing that and installing this XG7 card. But the guys that this came from, they're apparently novices with water cooling, so the card came in a bit of a sorry state, and we've got all the parts of the stock cooler, but what they've done is they've removed all the thermal pads and just tossed them away somewhere, so we don't have any of the stock thermal pads. Also the screws were missing as well, all the screws except for the 4 that just hold the X clamp to the GPU die. That was there, but the rest of the screws for the stock cooler were missing. We've managed to track those down, and I thought, with so many people having to probably look at second-hand or used markets, this could be potentially an issue somebody could face. There could no doubt be a lot of people water cooling these cars, especially if they're using them for mining or whatever. So it's potential that you could end up going out to, I don't know, pick up a car that you bought off eBay or Facebook Marketplace or something like that. It comes with a water block installed and a stock cooler, but you don't have any of the stock thermal pads. It's quite tricky actually to find a good diagram or a good image or any kind of teardown video, especially of this card. So it's not very easy to find out the thickness of the thermal pads you need for the VRAM and for the MOSFETs, and obviously for the backplate as well, because these 30 series cards have a lot of passive cooling on the backplate. So I thought it'd be a good idea to just do a bit of this video showing you how to kind of reverse engineer the thermal pad locations and thicknesses as well. So I've come up with a bit of an idea how we can do it, because I still haven't worked out what thickness thermal pads I need for the VRAM, for the MOSFET, and on the back of the card as well. So my idea is, now that we've got the screws and fixings, this was the X clamp, I call it, that came originally with the card, but then everything else just came in a bag like that. So I've not seen this card myself. I've not, stripped one down or taken one apart. So now I'm just left with a bunch of different size screws. There's probably 4 or 5 different length or different thread screws. Some are spring loaded, some are like Torx heads with just like a self-tapping thread on, and then the others they look like M2 or M2.5 threaded screws, and some of these have Torx heads and some of them have a normal Phillips head. So whenever I'm taking a stock cooler off to install a water block, what I'd normally do to just make sure that I kind of remember where the screws go, I tend to put them back in where they came from. So I'm just taking a guess now, like this one, see if it had come out of here, just loosely thread it back in, and then I'd store all the parts with the screws in somewhere safe, just in case I wanted to revert back to the air cooler in the future. But I didn't take this card apart, so it's like a big jigsaw puzzle putting it back together. So what I've done is I've just sorted the screws out into the different piles of the different types of screws and different lengths that we've got. There's 6 of these self-tapping screws with Torx heads. I think I've already worked out where these are from, because these have got like a silver head on them. And if you look on this fan shroud, there's 6 screws missing from here. These didn't need to be taken out to remove the stock cooler, but because these are self-tapping screws and they're threaded into plastic, I'm pretty sure that's where they go. But we've also got 4 more screws with Torx heads that are silver. These are actually a very fine thread. We've also got another set of screws with the same size thread, and it looks like they're the same length just about, but they're a Phillips screw. And then there's 3 countersunk Phillips screws with a larger thread on, and then 2 countersunk Phillips screws with a thread size in between those 2, and then there's 2 spring loaded screws. They're a Phillips head as well, and they're probably an M2 thread. I have actually had a look at some footage on video cards of a video by De Bauer. I think before this card was actually released, he actually managed to get his hands on one and strip one down. So I've got a bit of an idea how it goes back together. So the first thing is to put on this frame. This frame also acts as a heatsink for the VRM at the front here, so I do need to work out the thickness of the thermal pad for that, but it looks quite thin. That one maybe 1.5 mil or something, but I'll figure out how to do that in a moment. So we need that frame, and we also need the backplate as well. The backplate goes on at the same time as this frame. So looking at this backplate, There's an area with 4 screws that is in like a silver frame, very similar to the fan shroud on the top. So the wild guess would be that these torque screws go in there, and then they go all the way through and hold that frame in position. I think my Torx driver, I think we'll just put those in there temporarily. So they look like they're in the right spot there. So because of that, I'm thinking that the Phillips head screws with the same thread are likely to go through the back plate and into this frame as well. So I'll put those in there. So all those screws are in and tightened up. I'm pretty confident they're in the right spot, so what we'll do now is drop the heatsink on dry, so we don't need any thermal compound on for this. It actually locates on the back of the card. Just temporarily screw this X-clamp in. So the only screws left on the back plate are these 2 here, and then 2 at the top. These 2 at the top, I'm pretty sure, are for this GeForce RTX logo. So looking at it, these are countersunk. Yep, the 2 countersunk longer screws that we had. Looks like they go in there. And then the only other 2 on the back plate are these 2 back here. There's only 2 of these spring-loaded screws, so try those in there. I'm pretty sure that they're good. They are screwing in, so they look like they're the correct screws for there as well. So the only ones we've got missing now are the ones on the IO shield, and we've got 3 left of these countersunk screws. So again, I'm pretty sure that these are the ones for this, and they look like they match the other ones that were left in. So yep. So like I said at the beginning, all we're left with now is 6 of these with the silver Torx heads, these self-tapping ones, and it's obvious now that these are for this fan shroud, so these can go back in and these will stay in because they don't actually need to come out to dismantle the card. So we'll just screw those back in. That's the card back together. It wasn't as difficult as I expected actually. Luckily there wasn't too many different screws, and it was pretty obvious where all the different types of screws went. So that's not taken as long as I expected. But now we need to figure out, obviously, the thickness of the stock thermal pads. So what I've done is I've just had a look at some images online, and it looks like on the front side of the card, the areas that will have thermal pads on will be the MOSFET, the inductors, and the VRAM. And then the back plate offers some passive cooling as well. So on the back plate, we also need to find the thickness of the pads for the VRAM, the VRM capacitors, and the VRM MOSFET. To do that, I think the best way will be to try and use some of these feeler gauges. These are just basically strips of metal. They're really cheap to buy these as well. I imagine you'll get a set of these feeler gauges for less than £10 or $10. So they're very inexpensive. I don't use them that often. I do a lot of work on cars as well, so that's why I have these. Used to set tappet and valve clearances using these feeler gauges, but I don't tend to do that often these days because hydraulic lifters and everything like that, but I'll not get into that. What these are is they're just basically strips of metal, different thicknesses ranging from 0.8mm to 0.1mm, so that one is really thin. What you can do if you need different sizes that these don't cover, you could say put a 0.8 and a 0.2 together to get 1mm, or you could put together a 0.5 and a 0.2 to get 0.7. But yeah, that's what we're going to do. We're going to try and use these on here. So if you look down the front edge of the card, you can actually see the gap between the cooler and the different components that we need to find out the thickness of the thermal pads for. So looking down that edge of the cooler, you can see there's quite a big gap between the VRAM and the cooler that touches the VRAM. So I'm going to start off with 0.8 0.7 and 0.5 if I can find it. So that should give us technically a 2mm thick thermal pad. So that's very close. Let's see if we can make 1.5mm. So a 0.7, 0.8. That should make a 1.5mm pad. See, if you put the feeler blade down in between that, you can see that that goes in between the cooler and the VRAM. So it's obviously thicker than 0.5, but then when I put 2mm in, 2mm is tight, but it's very close. So I'd say for the VRAM on the front side of the card, we're going to want 2mm thermal pads. The VRM MOSFET is towards the back here, and there's also some under that strengthening plate. We'll start off, that looks a little closer than the VRAM, so we'll start off with 1mm, see if it's 1mm. Use a 0.7 and a 0.3 feeler gauge. And it's right down here at the edge. 1mm goes in quite easily, so let's see what 1.5 does. 1.5 again. That looks tight, but very close. So VRM MOSFET, we'll try a 1.5mm thermal pad first. When you put the thermal pads on and then put the screws in for the heatsink, it will compress the pads a little. So they're always a little bit big to begin with, and then they compress down when you put the cooler on. The only other thing really now is or on the front of the card, is the inductor for the VRM, and that looks like quite a huge gap actually. So I'm going to start off at 2mm, so 0.7, 0.8 and 0.5 feeler gauge, and that goes in between there, and there's a bit of a gap as well there. So to get 2.5, I'm just going to stick with the ones I already had, plus a 0.2 and a 0.3. Try and hold those tight and put them down. That looks close, very close to going in. So yeah, I'd say 2.5mm for the inductors on the front of the card. So we'll try 2.5mm pads on there. So now it's the back plate, and I just need to take this off. See if we can actually see down the back plate. So I have a feeling we might have to do this slightly different. So with the back plate removed, we can see that the majority of the thermal pads that will be going on the back of this card will actually be contacting with the PCB and just removing some residual heat that is generated by components on the front of the card. The method of working out the thickness of these pads on this 3080 is the same as the method for working out the pads on a 3090, but the only difference is on the back of a 3090, around the GPU die, you will have some VRAM chips on the back of the card. So that means the thickness of the pads between the 3080 and 3090 will be slightly different, although the method of working them out is the same. So the method that I'm going to use to work these out will involve using a digital vernier caliper. And what I want to do first is just close it up, set it to 0, then just measure the thickness of the back plate from the front to the standoff, which is 4.2mm. And then I also want to work out the thickness of the back plate itself, which is 1.75. So the reason I took those two measurements is to work out the difference in height between the face of the back of this back plate and the face of the standoff that contacts with the PCB. So if I just do 4.2 minus 1.75, that is 2.45mm. Just make sure that measurement is correct by using these feeler gauges. Just make up 2.5mm thickness. And if you just run your finger or maybe put a steel rule across there, you can feel that the standoff is in line with that 2.5mm feeler gauge. So what that means is the distance from the PCB to the face of the back plate is more or less 2.5mm. So any thermal pads that contact directly with the back of the PCB, they'll want to be 2.5mm thick. So the VRAM is 2.5mm and the VRM MOSFET That is also 2.5 millimeters. So now all we need to work out really is the height of these capacitors. So if we start off at 1.5 mil, that is just a touch too low. Add a 0.5 on to make the thickness up to 2 mil. 2 mil looks pretty much like it's the bang on right size. So what we're saying is the VRM capacitors on the back of the board, they stand up 2 mil proud of the PCB. If we just take off 2 mil off of the 2.5 mil difference we had earlier, I'd say that these need to be either 0.5 or at a push 1 mil pads. I think 0.5 will be alright because I don't think they really need that much cooling anyway. So now that we've got our list of thermal pads, or at least we think we have, we need to take the card apart completely again, cut some thermal pads to size, and then see if they fit correctly. Okay, so I've got the card all fully reassembled. What I've done is, it's kind of a dry run, so there's no thermal compound on the GPU die. All I've done is cut all the thermal pads to size, put them in place, and then just reassembled the heatsink and reassembled the backplate. I did have to change the thickness of one of the pads, the one on the front VRM MOSFET. I had that down as 1.5 millimeters and that was just too thin, so I changed it to a 2 mil and looks like it's all right now. So if you're confident that you think everything's right and you think you've got all the correct size thermal pads, you could technically leave the card now and just use it as it is. Obviously you would have had to apply some thermal compound, but what I like to do is just to be 100% certain, or just to double check that I have got all the thickness of the pads correctly, I like to, again, disassemble the card completely, take the heatsink and backplate off, and then you can check the thermal pads and you can usually see if there's any impressions of the memory modules and capacitors and whatever else. So that's what I'll do now. I'll just take all the screws out of the backplate, all the screws out of the heatsink, have a look at those pads. The card's fully dismantled again. We've got the three main pieces laid out on the bench, and you can quite clearly see on the backplate the VRM area that's making good contact with the thermal pad. You can see the impressions are really clear on there. Not quite as clear, but you can see there are impressions around where the VRAM area is on the back of the card. Obviously there's no VRAM chips on the back of this 3080, but you can see it's making contact with the PCB and with the resistor, the capacitors on the back of those chips. And you can also see on the front VRM section, again, really clear impressions there. Then on the heatsink that goes on the front face of the card. You can see again at the back where the VRM MOSFET is, we've got quite clear impression, so we can see that contact's good there. The VRAM area, the impressions aren't quite as clear, but that is pretty typical of this arrangement. You usually don't notice the impressions as much in the VRAM because it's a larger, flatter surface area, but you can see there are some impressions in there, so we know that there is contact between the thermal pads and the VRAM chips. So I'm pretty happy with how that's gone. Now if I was going to use this card with the stock air cool again, simply just reassemble everything, apply some thermal paste, and you'll be good to go. I'm not going to be doing that because I'm going to be fitting a water block, but I'm hoping that this has been helpful for someone else. I've not come across this problem before where I've bought a card used or second hand and it's had a water block fitted and all the bits have been lost, like the thermal pads and screws misplaced. But I could imagine that it is something that could happen, especially in this day and age where we've got these GPU availability problems, and I expect that soon enough there may be an influx of graphics cards on the second-hand market when either new ones are released or if there's some kind of mining crash or just an uplift in the production of cards. So hopefully this has been useful for someone. Now the most challenging part about this build is going to be what I have in store for on top of the power supply shroud. I want to try and keep the tubing for the custom loop in this system looking as neat and symmetrical as possible. So what I'm thinking is making a completely custom distro plate that's going to sit on top of this power supply shroud, and then tubing come from the pump to the distro plate, to the GPU, CPU and radiator, and try and, like I said, try and keep the tubing as symmetrical as possible. The thing is, I don't have access to any CNC machines or anything like that, so it's going to be made entirely by hand. I'm planning on making it out of 3 pieces of acrylic, bonded and screwed together, so it's going to be a challenge. I'm not sure at the moment whether it's going to work, but we'll find out. So first I need to make some kind of template really out of some card or something like that, just to map out where all the inlets and outlets are going to go on this distribution plate. So what I need to do is reinstall this XG7 block. This is the one that actually came pre-installed to the card when I got it, so I'm just going to reuse this for now, just install it temporarily back to the card, and then we do actually have a brand new XG7 for the final build. So I'm just going to put a few screws in this, and then once I've got this back together, I'm just going to temporarily install the motherboard, CPU, radiator, pump and the CPU block as well, so that I'll have all the inlets and outlets on the different components, and then I can take some measurements and figure out all the dimensions. Okay, so here is where we're up to so far. So I've installed motherboard, CPU block, GPU with the water block installed, radiator in the top, and the pump res at the front of the case. That's basically everything that will be needed for the custom loop other than the tubing, and that's what I'm trying to work out now. So I've cut a piece of cardboard, stuck that to the power supply shroud just temporarily, and that's going to be the template for the acrylic that is going to make up, hopefully make up, the distribution plate. So what I'm thinking is coming out of the pump res into the distro plate, then from the distro plate into the GPU, and then in a parallel flow out of the GPU to CPU, back from the CPU into the GPU again, and then from the GPU back to the distro plate. Now after that, we're going to need to come out, obviously, to get to the radiator. So in this corner down here, I'm hoping we can come out there and go straight up. May need a small 45-degree bend, either using a fitting or in the tubing, to get to the radiator. And then the only other way out now from the radiator is to put a 90-degree fitting on this side of the radiator and take it straight across, hopefully just missing the side of the top edge of the memory, and then into the pump res. If that works, and if we can do this and we can make this distro plate, that should look really tidy and neat. The tubing should look quite parallel as well, because we're just going to be coming straight up here into the CPU and straight up to the radiator. Hopefully that should work. So what I need to do really now is just to try and work out, obviously, where all the fittings and all the tubing outlets are going to be on this distribution plate. So I'm going to try and just more or less just eye them in with this ruler, maybe use the back of the case as a reference point, and then just measure to the centers of the tubes. And then if I want to get them 100% straight, I'm just going to have to try and eye them in best as I can with the straight edge. Okay, so that is quite a crude looking drawing, but it does give me a decent template, quite accurately showing where the inlets and outlets are for the pump, GPU, and the inlet or the outlet to the rad as well. So that should be a decent template for me to be able to at least transfer over those points where the inlets and outlets are to acrylic. I've also marked up on the power supply shroud whereabouts the this template fits, so I should be able to line that up again pretty easily when I get the first prototype made. I'm not 100% sure about these channels. I might widen those out and make them so that they go around the edges of the fittings as well. I think they might look a bit better, a bit wider and a bit more chunkier. And I also might change the shape of this one as well. I don't know whether those straight lines are what I want, maybe put it a bit more curved. We'll come to that later on when I start actually making this out of acrylic. I've also put potentially a drain in there as well that I'm hoping would come out of the bottom side of the distribution plate, because there is actually a drain port on the front of the case, so I could potentially put a drain, maybe connect it up to one of these channels and then put it down through the power supply shroud and use maybe some flexible tubing straight to the front of the case. So that is the basic template. Hopefully I'll be able to make up something that works by using this template. So now I need to decide what colour acrylic I'm going to use. I definitely want it to be black to fit in with the theme of the build. So far it is looking good. It is more or less a blackout inside. I still need to decide what I'm going to do with the colour of this power supply shroud and the motherboard tray. I'm thinking carbon hydro dip for those, as well as some more carbon hydro dipping on the outer panels as well. But I want to order some acrylic for that, and what I'm thinking is maybe go with a clear frosted acrylic top, and then because it's going to be a 3-piece acrylic design, possibly 3 5mm thick cast acrylic sheets. That's what I'm thinking at the moment. Maybe one of them might need to be upgraded to 10mm. Maybe the central one, what will make the channels, that might need to be 10mm. But it's going to be 3 pieces, so I'm thinking maybe a frosted clear top and then a matte black center, and then on the bottom it probably doesn't make much difference what it is. I might just go for another clear frosted bottom as well, and then hopefully you'll see the majority of it will be a frosted matte black, but then you will be able to see the coolant running through it with that frosted clear top. And what I'm hoping as well is by using a frosted clear top, it will hide any adhesive or sealant or plastic weld that I have to use to bond these 3 pieces together. So hopefully next time out I should have the acrylic here, and that's what I'll be working on. I'll be transferring this template design to the acrylic, and hopefully by the end of the next part we should have hopefully a fully working watertight distribution plate that fits perfectly on top of this power supply shroud, and hopefully it'll line up with all the inlets and outlets on the GPU and everything, because my template will be perfect. But yeah, that's fingers crossed. Hopefully that's how it'll go down. If it doesn't, then we'll have to think of something and maybe just doing a traditional hardline setup, but try and make it look as neat as possible as well, trying to use probably another parallel flow system, because that does tend to look a bit neater and tidier. But so far I think it's going to plan. Thanks for watching this part. There's going to be more to come of this video. It'll be a 2 or 3 part series at least, this spanning over the next probably month or so. So make sure you keep up with the series if you're interested in this build, and let us know in the comments as well what you think of the way that this build is going. Do you think that this distribution plate is going to work, making it by hand without any CNC machines? I have got confidence in it, but sometimes I have a bit too much confidence and it doesn't work. But let us know what you think, and I hope you enjoyed watching. Don't forget, if you want to help support KitGuru, you can always head over to our store, pick up some KitGuru merch. And if you've enjoyed watching this video and you like this series, give us a thumbs up and also hit that subscribe button. And as always, you can head over to KitGuru.net to catch up on all our in-depth hardware reviews, catch up on some tech news, and if you want to keep in touch with us, you can do on Facebook, Instagram, Twitter, and you can also head over to our Discord channel. Thanks for watching, guys. I'll see you next time.